All right, so for this third one, it's not that hard, but it is very specific. So we have that the depth of water, W meters, in a particular harbor can be modeled by the function WT equals blah blah blah, where T is the length of time in minutes after 6 o'clock. Interesting. It's in minutes and it's after 6 o'clock. On the 20th of January, the first high tide occurs at 6, at which time the depth of the water is 18 meters. So here is an important piece of information. Then they tell us that the following low tide, okay, so let's use a different color. The following low tide occurs at 12:15 when the depth of the water is 4. This is shown in the diagram. So for example, the thing in yellow that the high tide occurs at 6, at which the time of depth of water is 18. Well, this whole diagram is time in minutes after 6. After 6. So for example, at t equals 0, what time is it? At t equals 0, it's right at 6. Because this diagram is minutes after 6. And so 0 minutes after 6 is at 6. T equals 1 would mean I'm talking about 6:01. So that being said, this thing in yellow over here, right, we're going to have, over here we're going to have the point 0, comma, 18. So 0 minutes after 6, the depth of the water is 18 meters. All right. So that is the first piece of information that gets shared with us. And then it tells us that the low tide occurs at 12:15 when the depth of the water is 4 meters. And so that means that at 12:15, which is when the low tide occurs, so it's this lower point over here, right? We're going to have a height of 4. And so, well, what x value is this, right? Because my x is time, right? And we're talking about the low tide occurs at 12:15. Well, from 6 to 12, how much time passes? How many minutes? Well, it's easy to see after you take a moment that it's a 6 hours, right? Because there you reach 12 and then you add 15 minutes. But we want it all in minutes because those are the units we're working for t, right? And so time in minutes, well, you take that 60, you take that 6 hours, you multiply it by 60, so 6 hours multiplied by 60, these are the hours portion, and then you do those plus 15 minutes. And so you have 375, so this point right here is 375 minutes, 4 meters. All right? Notice how we haven't even started the exercise, but already our diagram looks a little more friendly than what maybe it should look like. See? So that is something, a good habit to do. Make sure that your diagram has everything like written on it that it says. See? Or try to get all the juice out of what they're giving you. See, that's basically what I'm trying to say. So there we go. For part A, we need to find the value of A. And now here's what I meant earlier that this exercise is not that hard, but it is awfully specific. Here we have what is called a cosine function. I mean, it literally says there, cosine, right? And so this cosine function, there are some specific properties or things about it you just kind of like need to know, okay? I know it's a little bit unfortunate that I put it that way, but I'd rather just be honest with you. This is not in the formula booklet. This is the kind of thing you just gotta learn, okay? So when you have this equation here, so WT equals A cosine BT plus D, there's a couple of things that we really need to understand. So first things first, this A, every time it's in front of the cosine multiplying, it's what we're gonna call the amplitude. The other big important piece of information that we need to learn is that D, okay, D is the vertical, I'm pretty sure it's translation, okay? It's the vertical translation. And so depending on how A changes or how D changes, you have a cosine function that is slightly more different in specific ways. I know that didn't sound too specific, but let me just show you real quick what I'm talking about. So let's say I have this A, and then let's say that I have this being multiplied by cosine of, I don't know, x, and then I have our famous um, slider thing. See? So imagine that D like doesn't exist. See? Imagine that D is equal to 0. So this is like your starting point for the cosine, right? And so what the vertical translation does is that as it grows, your function literally goes up, okay? It doesn't change in any other way, but it goes up. For example, when it's equal to 2, notice how now sort of like the middle part of it, okay, where it cuts through the middle. What I mean by cut through the middle, I mean this. When it cuts through the middle, is now up 2. But if it's up 1, now it cuts through 1. If it's in its starting point, how it comes from, it cuts through 0. And so that is a little bit what the vertical translation does, okay? And what the A does is the amplitude. So let's go from an A of 1 to an A of 10. What is happening here? Well, the waves still come at the same frequency, right? It's not like the waves are coming faster, but the waves are much bigger. And so with that in mind, we can understand a little bit better what amplitude is. Notice how value of A right now, well, from here, from the 0 all the way up here to the 10 is 10 because my A is 10. If my A is 11, now from the 0 all the way up there, it's going to be 11. All right, so that is just a little bit of a quick 101 on cosine stuff, right? And just to really have us all understand this a little bit better, let's say you have a cosine function that looks something like this. Okay, and there's a lot to it, but I'd rather just show you what you need, okay? Um, the amplitude, okay, is imagine you're cutting it in half, all right? The amplitude is always going to be from the middle to the top. So for example, this is one amplitude that you can also think about it as like from here to here. And this is also an amplitude, which is thinking like from here to here. So that is what the value of A does. The A is the amplitude, okay? And the vertical translation, well, it's a little bit like the orange line, but honestly, it's like, so it starts at 0, 0 like this, right? And the vertical translation makes it, I don't know, move up maybe like a whole unit, see? So you end up with that. That's what the vertical translation does, okay? B is this weird thing that has to do with period and this or that, but for this exercise, doesn't matter. I'm not gonna confuse you with more stuff. This is the cosine function, okay? So what can I do? For the value of A, well, what information do I have? I have these 2 points. So I have 0, 18, and I have 375,4. So let's go ahead and plug in both and see what happens. Okay, when in doubt, just plug in a point, see what happens. So if I plug in this first point, 0, 18, I end up with, let me just, yep, so this is my function. So if I go ahead and plug in 0, 18 here, you end up with 18 equals A times cosine, parentheses, B times 0. So T is equal to 0, right, in this point. And B times 0, anything times 0 equals 0. Anything times 0 equals 0, so I ended up with cosine 0. Now, what is cosine 0? Cosine 0 is 1. So this whole thing now turns into 1. So A times 1 plus D equals 18, which is the same as if I write A plus D equals 18. See? So this is the first sort of thing that we're going to obtain. And if I plug in the second point, that's 375,4, well, I end up with 4 equals A times cosine 375 times B plus D. And so this second one, well, neither of the two help me so much right now, because in the first one I have two variables, right? And in the second one I actually have three. And so it's hard to solve it from here. It's hard to know what to do, but hey, we wrote our equations. This is what we have. We tried plugging in the points. We're not there yet. We gotta keep digging. See? So again, I'm just showing like the right procedure. Lay out all the information first, really understand what's going on, and then get playing. See? And so this is what I have. It's not enough. So the answer is going to be a little bit elsewhere. And this, again, apologies, it comes back to knowing really specific stuff about this specific problem, because you just got to learn cosine and sine and all that stuff. See? So remember how I said that these are the amplitudes? And that technically there's two of them, one that goes here, one that goes there. And well, this repeats all along, right? Well, technically, right, the amplitude can be expressed in a similar way. So notice how here you have like the maximum, right? And notice how here you have the minimum, okay? And the maximum minimum keeps on repeating. It's always the same maximum and minimum, right? So what does that help me do or identify? Well, the amplitude, right, is gonna be half the distance. What do I mean by this? From here to here, okay, from the max to the min, half of this is the amplitude. Okay, so from the max to the min, half of this is the amplitude. From the max to the min, half of this is the amplitude. I know it's starting to sound insane, but that is the main idea. The amplitude. From the max to the min, half of it is the amplitude. Okay, so what is my max in this context? Well, it's 18. What is my minimum? 4, right? So from the max to the min, half of it is the amplitude. So 18 minus 4 gives me 14. Divided by 2 gives you 7. This is a general math rule that you can do. It works in cosine always. If you're not convinced yet, let me give you another example. Imagine you have a cosine line, okay? And we know that this is a height of 2, okay? So this is going to be 1, this is going to be 2, this is going to be 3, this is going to be 4. So this is a height of 2 and this is a height of 4, okay? Well, the amplitude is going to be from here to here or from here to here, see? And so you can see very easily that, well, from 2 to 3 is 1, from 3 to 4 is also 1. And so the amplitude is 1, right? Visually appealing, makes sense on the number line. I feel like you'd be convinced, see? Now, what's the mathematical nerdy formula that you can do? The max, as I said, from the max to the min, so 4 minus 2, half of it divided by 2 is the amplitude. So 4 minus 2, oh fuck, 4 minus 2 is 2, divided by 2 gives you 1, which is the same one that I just showed you here. Alright guys, that was just to convince you that what I did here is legal, okay? And if you still don't trust me, look at the answer key. That is quite literally how they do it. 8 minus 4 divided by 2, okay? So that is how you find amplitude. In this case, from the max to the min, half of it is the amplitude. For part A, we will be putting that A equals 7. Let me take this over here. All right. So that is for part A. For part B, we need to find the value of D. So because we took a moment to really write down all the information in our diagram beforehand, it helps a lot along the way. And so you have all these tools in front of you. You have to solve this problem. You now know that a equals 7. So what is the key information I wrote down earlier? These two equations. And I know that a equals 7. So if a equals 7, well, the value of d is extremely easy. You can plug it in over here. You end up with 18 equals 7 plus d. So minus 7 minus 7, d equals 11. Just like that. So for part B, d equals 11. All right, guys, so notice that for parts A and B especially, which are 4 pretty easy points, all you really had to do was understand the sine function, okay? So I know some of you might be thinking, or you guys never really reviewed well the sine function or the cosine function or whatever, but just knowing a little bit about it already gets you 4 points, dude. I mean, all you really needed to do is understand the amplitude and the max to the min thing, and maybe understanding this example I gave of the 2 and the 4 for the maximum, for the minimum maximum, right? And that way you never forget what amplitude is, you never forget how to get it, it makes sense, and just like that, you have parts A and part B pretty easily. See? Well, you also have to plug in a point, but that isn't so crazy either. I mean, when in doubt, plug in a point. Honestly, when in doubt, just plug in a point. It's usually the way to go. So I'm just saying, guys, 4 easy points, just understanding a little bit what a cosine function is. Now it gets a little bit more juicy, right? Because here, the buzzword that shows up is find the period of the function in minutes. So that's something we haven't talked about yet. The period of a function, think about it this way. So the period of a function is from max to max or from minimum to minimum. What do I mean by this? In the case of from max to max, yeah, it would be from this guy to this guy. So whatever that distance is literally going to be the period. From the minimum to minimum, so min to min, right? It would be like from this guy to this guy, right? And this would also be, ladies and gentlemen, the period. Period. See? So the blue distance and the green distance are the same. Okay? The period of the cosine function is always the same. Don't trust me? Well, it's about time that you did. If you look at this equation over here, right, which is the most generic way possible, see? This maximum is 0, 1, and this maximum is, well, 2 pi, 1. So from 2 pi, 1 to the next one is 4 pi. So the distance between these two, I know pi is in between, it's kind of scary, but dude, the distance from one max to the other is 2 pi. So you're willing to bet that the next one is going to be 6 pi. And so you're doing plus 2 pi every time. See? So that is what the period does. If I look at the minimum, you're going to end up the same thing. So if this is 3 pi, the next minimum has to be 5 pi because the period is 2 pi. So 3 pi plus 2 pi, a whole lot of blueberry pies, 5 pies. See? Whatever, guys. That's just so you guys understand what the period is. Okay? So in this case, we need to figure out what the period is with the information that we have. Now this part you have to be a little bit more creative because technically in this diagram, I would have to draw all the way over here and then find the period from here to here. See? But I don't have that. I don't have that. And I also can't graph this yet in my graphing calculator because I don't have it. You know? So how can I figure out the period? Well, what do you have? You have a high tide and a low tide. But that's not the period. Or is it? Is it the period in another way? Well, let's think about it. So if we come back to this exercise here, and I know it has the pi's and it's a little bit confusing. But still, stick with me. So this maximum is 2 pi. The next one is 4 pi. And the minimum in between is 3 pi. Oh shit. Okay. what am I trying to tell you? So in this sort of diagram that we just saw, we had we had, for example, here we had 2 pi. Here, let me make another diagram, or else it's gonna be hella confusing for some of us out there. So, what am I trying to express? Just so that we're all on the same page. Okay. This thing that I have in decimals, okay, from one period to the other, right? So this is 2 pi. And when I say pi, it's like in distance. Okay. So this is 2 pi, right? This is 2 pi. And then and this is height of 1, okay? And this is 4 pi. And so the period, much how we said from max to max in blue, right? So the period, the period is going to be that distance. How much is that distance? Well, you do 4 pi minus 2 pi gives you 2 pi. So the period is 2, right? And imagine we don't know that this number up here is 4. Okay, we don't know that. All right, we don't know that, but we do know that the minimum right next to it is 3 pi. Ah, so what you can do is that technically from a maximum to a minimum, it is halfway of the period. Okay, so from max, distance of max to min is half a period. Okay, the distance of max to min is half a period. This distance here is how much? It's 1 pi, right? So if this is 3 pi, the distance right here is just 1 pi. And so if you add another 1 pi, you reach the 4 pi here, which is this maximum there. See? So all I'm really trying to prove or tell you is that the distance of max to min that are next to each other, right, is half a period. What do I have here? Da, 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 da. I have a max and a min that are next to each other. And so technically, if I take those two, find the distance, and multiply by 2, because here we have half, you get the full period. So right now we have half a period, I can find the full period. And so half a period, oh look at that, we already did it, we already put the points. So half a period is from 0 to 375. Okay, and so from 0 to 375 is half a period. I'm literally going to write this first. So half a period is 375 minutes. Therefore, a full period is 375 times how much? Times 2, which gives me 750 minutes. If you want to be really, really technical about it, you would first put time between max and min is 375 minutes, right? That way you make sure you get full credit. You want to make sure you say extra stuff and exercises that have 3 points, okay? Usually when they have 2 or more, you have what's called method points, which is like proving that you know what you're doing, basically. Showing your procedure, showing your work. Whenever there's 2 or more points, definitely when there's 3, there's procedure points, okay? So this line right here can net you a whole ass point, I promise. See? This right here can get you a whole point. So that is 1 point. This is probably like the second point at times 2, and then getting the right answer is the third point. See? All right. That is for part C. Then for part D, we need to find the value of B. All right. From here, actually, we could have done this just with part A and B. See? I'm going to show you why. But when in doubt, look at what you've done. Look at the tools you have. See? And so the tools I have, well, you have A, you have D. And so this A, I already have it. This D, I already have it. This A, I already have it. This D, I already have it. Ah, remember originally I said the problem with this second equation is that you had how many variables? It's that you had 3. You plug in A, you plug in D. How many variables do you have? You have just 1. You have B. which is what you're looking for actually. So 4 equals A, which is 7, times cosine 375 times B, which is what you want, plus 11. All right, and from here, okay, from here, we can try to solve it with some simple sort of algebra and stuff, see? And so because we want to get B alone, first get rid of everything that's around it, particularly on the outside, see? So on the outside, we have this plus 11, that's a little bit annoying, so I can do minus 11. So if I do minus 11, this goes away with this, I end up with negative 7, right? Yeah, I end up with negative 7 equals 7 times cosine 375 times b. What can I keep doing from here? Well, the cosine is being multiplied by 7, so you can divide by 7. So compound, you end up with negative 1 equals cosine 375 times b. Now, this next part is a little bit weird, yes, but let's understand what we have to do. So right now, the b is inside a cosine, right? Let's imagine you have 2x equals 4, and I tell you solve for x. Well, of course, you're going to tell me, duh, you divide by 2. But guys, why do you divide by 2? You divide by 2 because 2 is the inverse operation of multiply. Okay, so what is the inverse operation of cosine? Ah, the inverse operation of cosine is quite literally, ladies and gentlemen, cosine inverse. So you can do cosine inverse to both sides. And what that helps you do, well, if I go ahead and do cosine inverse over here, right? So I can do cosine inverse of negative 1, I end up with 180. So on this left side, I end up with 180 equals, well, the cosine inverse makes this go away with this. The parentheses inside, whoops, the parentheses inside stays the same. Okay, so I end up with 180 equals 375 times b. So you want to keep getting b alone, well, you divide by 375. Divide by 375 to both sides. This goes away with this. B equals 180 divided by 375. In other words, B equals, let's figure it out, 180 divided by 375. Bada bim, bada boom, 0.48. So the value of B is 0.48. That is for part D. Now guys, remember, a lot of this has been sort of fast or quicker because we plugged in the 2 points at the beginning. See? Plugging in the 2 points at the beginning, you know you're going to use this eventually. I just couldn't use them yet. Alright, but that is good procedure because you have all your alternatives right in front of you. Guys, a good procedure isn't like knowing exactly what to do and perfectly in the quickest way. Dude, screw that, okay? That doesn't matter. A good procedure is knowing all your opportunities, knowing all your options, knowing all the paths, okay? And seeing what works best. And so I first wrote down those two equations. I actually couldn't even use them immediately, but they were there, and I knew that they were there. And so the moment I found A, right? The moment I found A, I could find D. The moment I had A and D, I can find B. And the only way I can really see that if I write these equations, I use a little bit of color coding, and I remember, yeah, okay, the one on the bottom has 3 equations, the one on top has 2, and so that can help you like really approach the problem in a better way. Okay? So that is that for part D. Then they tell us that Niobe is sailing to the harbor on the morning of the 20th of January, and boats can enter or leave the harbor only when, important words, only when the depth of the water is at least 6 meters. So for part E, we need to find the latest time before 12, another keyword, before 12 to the nearest minute, sure, that Naomi can enter the harbor. Okay, let's understand this a little bit better. So they can enter or leave only when the depth of water is at least 6 meters, or else their boat probably gets stuck or some shit like that. See? So 6 meters is just around here. See? So if I go ahead and draw a line that cuts like this, actually let me use a different color. If I draw a line that cuts like this, again, not the straightest line in the world, but you guys get the idea. We need to find the time before 12, as it says here, the latest time before 12 that Naomi can enter the harbor. And so where is 12 in my graph? So 12 is how many hours after 6? Remember that our diagram is always thinking about after 6. When t equals 0, you are at 6. When t equals 0, you are at 6. And so to reach from 6 o'clock to 12 o'clock, how many hours is it? Easy peasy, it's 6. So from 6 to 12 is 6 hours. How much is that in minutes? Well, 6 times 60 gives me 360. And so where in my graph I have 360 is exactly when it's 12 o'clock. Ah, okay. So that means that, well, this is a 375, ¿cierto? This is a 375 from earlier. But right now, what I'm really focused on is that this here is when it's 12 o'clock. Okay? And so Naomi can enter or leave whenever we're above the famous 6 meters. And so Naomi can enter or leave anywhere around here. Naomi can enter or leave. See? Well, as a matter of fact, also over there. See? Let me be very specific. She can enter or leave here or here. Okay? And so, well, now it's pretty obvious what we have to do. We got to find this piece of time. And from that or beforehand, Naomi can enter or leave. See? Aha, okay. So find the latest time before 12 to the nearest minute that Naomi can enter the harbor. Here, what really works out well, see, is understanding the following idea. This purple line equaling, I mean like this 6, see, the moment it equals my cosine function, right, they are intersecting. Guys, when two lines intersect, they equal each other at that point. What do I mean by this? Whatever this point is, whatever this x comma y is, they both share that x comma y. So they are equal to each other. Okay, so if I create an equation for both of these lines and equal them to each other, I can find the intersect. Yeah. So my first line, we can call it 6. Y equals 6, right? Quite literally. Y equals 6 looks like that, which is what I just drew. Y equals 6. See? Let me get rid of these things. Yeah. Y equals 6 is right there. See? Yeah. And the other line, well, that I have all the information now, because I finally know what A is, what B is, what D is going to be, well, it's going to be blah, blah, blah. This equation, right? I just gotta plug in from all the different parts. So this equation is A, which we said was 7. So 7. Cosine B, we found was 0.48 times T, which is my variable, plus D, which we said was 11. So here I have my two equations, and I can equal them to each other. See? Let's look at it on decimals first, just so we understand exactly what we're doing. So my first equation is up there. My second equation is 7 cosine 0.48 t plus 11 plus 11. See? And so wherever these intersects occur, right, is basically going to be like what I need. See? So Naomi can enter or leave anywhere in this area here. see? Anywhere above that 6, right? And technically over here as well, she can enter or leave anywhere above that 6. Now, of course, you're not going to have decimals the day of the test, but you're going to have something a little bit better. Da-da-da, your graphing calculator. See? So, y1 we can make it 6. Y2 we can make it our equation, which is 7 cosine 0.48, my variable t. In this case, I press the variable button. I get x plus 11. So if you go ahead and graph, well, there's my 6. And I clearly did something wrong. So let's check our work. Y1 equals 6. Y2 is 7 times cosine 0.48x plus 11. Okay, it looks right. So what is happening here? Maybe we just gotta play around with our window. See? So for the window, let's imitate what the problem gives us. So we can have a y min of 0 and a y max of 20. Okay? So y min 0, max of 20. And my x values can go from 0 to 480. See? So let's go ahead and do that. And maybe my graph makes a little more sense. Okay, awesome, awesome. I'm very glad that happened. Just to show you guys that sometimes the calculator is never wrong, okay? If anything, you're wrong. But it's good to keep that in mind because what I put in y equals wasn't wrong. I double checked it was right. So the mistake was elsewhere. The mistake was in my window. Okay, I was taking a window like too small of my graph and the lines looked both flat, which didn't make sense. I knew it. So I changed the window and now it makes sense. See? Happens to anyone. Just keep it in mind, you guys. See? All right, so back to the problem. Technically, Naomi can go enter or leave anywhere above this line. So you need to find this exact point and go and say, okay, from here backwards is when she can enter or leave. See? To find that exact point, we find the intersect because when two lines intersect, they equal each other. And so let's try to find that x comma y. Let's see what it is. We can use the calc intersect trick. So we press second, right? Trace to hit the calc button. Go all the way to intersect. You can press the first curve, which usually picks it up by itself, so the flat one. And the second curve is the one that is curvy. See? Then we have guess. Guys, the guess function is really just to pick your intersect. So notice how there's an intersect here, and technically there's also an intersect all the way over there. See? And so the guess function helps you pick which intersect. It's not that your calculator is dumb and needs help finding the intersect. Nah, dude. This guess thing is for you to pick which intersect you want to know about. So I'm going to know about this one more to the left because 12 o'clock is like right there. ¿Cierto? More than that is past 12. Yeah. So that point there is 282 46811. So this point here is 282. Give me 1 second. We have 282 468 minutes, right? 468 minutes. So from there, like backwards, is the time that Naomi can enter the harbor. See? Now, 282.468 minutes is how much after 6? Yeah. So I can take this 282, okay, 0.468 minutes, and see how many hours and minutes specifically I have here. So the first thing I can do is take that number, the 282.468, right, and divide it by 60. So what this gives me is that I end up with, well, I end up with 4.7, right, 4.7078 hours, right? Another way that you can kind of try to approach it, see, which now that I think about it is a little bit more intuitive. So if you divided it by 60, you got 4 point something hours, see? So 4 hours enter nicely into this. And then this amount here is like some amount of minutes, right? All right, so I got 4 point something, so that means I can put 4 hours here. See? Now, how much is 4 hours? Well, 4 hours is 4 times 60, which is 240. So I can write that this number here is the same as 240 minutes, okay, plus the remainder. So I can do 282. I can do this 282 minus the 240. So the remainder is 42.468 minutes. If you want to get really technical, you can say that this is 4 hours plus the 42 minutes. See? Now, because it's to the nearest minute and because the context of the question, it makes sense to round down. That's fine. Well, and you are rounding down because it is 4. You can leave it as 4 hours and 42 minutes. Now, from 6 o'clock plus the 4 hours and 42 minutes, how much time is it? Well, 4 hours, 7, 8, 9, 10, plus the 42 minutes, 10:42. Notice how this is worth 4 points, so you definitely want to be writing a lot of these different method points and stuff, see? But that is for part E. So the latest time before 12 is 10:42. All right, it makes sense to round down because we're thinking about like the nearest minute beforehand, right? So that is for part E. Got it? Then for part F, it says find the length of time in minutes between 6 and 3 on the 20th of January, through which Naomi cannot enter or leave the harbor. So the first question, of course, is where exactly cannot where can she cannot enter or leave the harbor? So we just found that 10:42 and like before that she can enter or leave. So right here, this right here is the famous 10:42. That thing in blue is 12 o'clock, and whatever this is going to be my length of time. See? So actually, where is 3 o'clock? See, because they are telling us between 6 and 3 o'clock. And so 3 o'clock from 6 to 3 o'clock is how many hours? It's going to be 6. It's going to be, well, from 6, right, to 15. Oh, here it's more easy. You can do 15 minus 6. 9 hours. See? 9 hours, well, 9 times 60, 540 minutes. And so the 540 is around here. See? So basically, the exercise is asking you, okay, in this function, between 6, which is what I'm seeing here, and 3 o'clock, which is here. Wait, was it from 6 to 3? Yeah, from 6 to 3. So from all of this part, where is it that Naomi cannot enter or leave? So the only place she cannot enter or leave is when it's below 6 meters, and the only part of my diagram that is below 6 meters is this sliver right here. And so if I find the intersect on the left, which I just did from part E actually, which is 10:42 minutes, at 10:42, if I just find whatever time is here, well, that is going to be my length of time. See? And so, once again, watch how the AB likes to do it. Part F needed something from part E. It's not always the case, but today it was. See? And so, I can open up my graphic calculator, I can go to my y equals, and remember how I said that using the intersect, you can pick which intersect with guess? So, pick your first curve, pick your second curve, and with guess, pick your second intersect. And so if I pick this second intersect just around here, right, it's the same as picking or asking my calculator what this point is. See? Which is exactly what we want. Go ahead and guess. There it is. And so that right here is 467 minutes. So 467, let me write it down, 0.53, okay, 0.53, 1 minutes. Okay? And so technically, If we want to be really clear about it, well, I can divide this number by 6. Follow a little bit the process before, just so that we're on the same page. So this divided by 60, sorry, gives me 7 point something. So that means I can put 7 hours into this with ease. So 7 times 60, yeah, 420. So this is 420 minutes plus the remainder. So 467.531 minus 420, an excellent number, gives you 47.531 minutes, right? Now the 420 minutes is the same as 7 hours. See, so I can write this as 7 hours plus 47 minutes. See? And so from 6 to 7 hours plus 47 minutes, well, you do plus 7, so 6 plus 7 gives you 13. So you end up with 13 hours, 47 minutes. See? So this right here is 13 hours, so 1 o'clock with 47 minutes. Okay? And so if I do 1 o'clock, 47 minutes, minus 10 o'clock, 42 minutes, well, how much do you end up with? You end up with 3 hours and 5 minutes. See? And I know that subtracting time like this can be a little bit weird, but if you take your time, I'm sure you're gonna get it. So this minus 1042, I think it was, yes, minus this. You can think about it this way. On the one hand, you have the hours being subtracted to each other, okay? And on the other hand, right? On the other hand, you have the minutes being subtracted to each other. So this gives me 3 hours. This gives me 5 minutes, which is the same as saying that this 180 minutes plus 5 minutes gives you 185 minutes. See? All right, that was a little bit more extensive and a longer way to get like the answer. But just so you know, I wanted to show like how you manage time, how you deal with time in a mathematical perspective. A quicker way to solve this, I'm just showing you the long way so you understand what's going on behind the scenes, okay? Like this is what we're doing at the end of the day. We're taking 2 times and subtracting them, see? A quicker way to do this, now that you saw the boring way, a quicker way to do this is that you just take the equivalent in minutes. So this one is this one. Meanwhile, this one, oops, I actually fucked that up, sorry. Let me go with that again. I'm leaving that in the video because we can all fuck up. So this one, the 467 minutes, is this one, the one that's farther out. And this one, the 282 minutes, is this one, the one that's earlier. See? And so technically, here I did green minus red, right? Well, let's do that again. Let's do green minus red up here. So we can take that 467.531 minutes minus what's in red, which is 282.468. Lo and behold, you still get 185 minutes. See? So a quicker way to do it, but I think it's a little less intuitive if I'm telling you to subtract these minutes. I'd rather first show you what's really going on, right? You're subtracting 1 o'clock with 47 minutes to 10 o'clock with 42 minutes, but you can put it all in minutes and it's the same way. See? So green minus red is the way to go. That is part F. And as I said, you guys, this exercise is not that hard, but it is awfully specific. Okay, if you're not familiar with the period and the amplitude and all that shit, there's not much you can do. I'll be honest. There's not much you can do. But just knowing a little bit about it, just understanding what amplitude is, memorizing or learning this thing, right? What the period is, or learning this thing, that from a max to a min is half a period, or learning this thing that from the max to the min, half of it is the amplitude, or visually what the amplitude is. Just that, which is not too crazy, you guys, but just that is enough to net you wide a few points. So there goes the exercise. The problem number 3. I hope it helped.